right, let's knock out this practice test. Let's notice on the first one, we've got two terms. It's not a difference, but we always want to remember to take out the GCF first. That's the first rule in factoring. So we've got a 64 and an 18 as far as coefficients go. So the biggest thing we can take out of both of those is a 2. Then we notice that we've got an a cubed and an a squared. So the most we can take out is an a squared. We've got a b squared and a b cubed, so we can take out a b squared, and here's what we're left with. Remember, we're dividing out, we're not subtracting out. So this is going to leave us with a 32 when we divide by 2. We took out 2 of the a's, so that's going to leave 1 of the a's, and we took out both of the b's. We're going to take a 2 out, so that's going to be left with a positive 9. We took both a's out, and there's 1 b left. So this is the answer right there, all finished. Let's take a look at the next one. We've got 3 terms here. Again, we'll notice that we've got a GCF. We've got a 2 that we can take out, and we always take out the leading sign. That first one's positive, so we're in good shape there. We'll notice that every single one of them has at least one x, so I'm going to take out an x. And we notice that each one of them has at least one y. So we're going to take out a 2xy, and let's write down what's left. If we take a 2 out of a 6, we're left with a 3 because we're dividing. We took one of the x's out, so there's one left. One of the y's out, so there's one left. Took out the x and took out one of the y's, so we're left with a y. But remember, there's always a 1 left, so this is a negative 1y. And then we took out a 2, so that's going to be a 3. Took out one of the x's, that's left with an x squared. And then we took out one of the y's. So we take a look in here. This does not fit any of those trinomial patterns. We'd have to have a y squared over here and an x squared on the end right there. So that is the answer to this one. We'll take a look at the next one. We'll notice that there are 4 terms. And if there are 4 terms, the only way we're going to be able to factor that is by grouping. So we're going to go ahead and group the first 2 together. So I'm just going to group here and here. So we're going to take out a 3a squared. If I take out a 3a squared, I'm left with just a plain old a. If I take out a 3, I'm left with a negative 5, and took out the a squared, so nothing left there. We need to take something out of here. They don't have anything common other than a 1, and we're going to take out the leading coefficient, so that's going to be a negative 1, and we're left with an a minus 5. And this makes us feel good because we've got an a minus 5 common to both of those. What we're left with of this first term is going to be a 3a squared minus a 1. We always want to factor completely. We might notice that we've got a perfect square of 1, but this is not a perfect square. 3 is not a perfect square, so we're going to leave it right there. Again, you can always write these in an opposite order. You could write this as 3a squared minus 1 and then a minus 5. That would be okay too. Nothing wrong with writing the answer like that, as long as the right sign goes with the right term and stuff like that. On this one right here, we've got 4 terms. So again, we're going to group like this, first 2 together and last 2 together. We're going to take out an n squared. We're left with an n minus a 3. Out of here, we've got to take something out. We can take an 8 out. We always want to take out that leading sign, so we're going to be taking out a positive 8. We're left with an n and a minus 3. So I've got an n minus 3, and then I've got an n squared plus 8 left on this one. Again, no difference of squares or anything like that, so we're done factoring that one. Bring that back there. Okay, let me slide down. We'll take a look at a couple more. This one is a trinomial, and you'll notice the way this is written. This is an easy trinomial. It starts off with a 1y squared, so this is going to factor to y and y. And I need 2 numbers here and here that multiply to be positive 4 and combine to be negative 5. Well, if they're going to multiply to be a positive and combine to be a negative, we need a negative in each one of these places right here. And I'm going to do a 4 and a 1 because I can make a 5 out of those. So we are done with that one right there. And then take a look at the next one. This is similar. Again, easy trinomial starts off with a 1. So we're going to have an m and an m to make the m squared. And then I need numbers here and here that multiply to be negative 27 that combine to be negative 6. So think about that for a second. Numbers that multiply to be negative 27 combine to be negative 6. That is going to be negative 9 and positive 3. They're going to multiply to be a negative, and if they multiply to be a negative, one has to be negative, one has to be positive. And then if they combine to be a negative, the bigger one has to be negative. So we've got m minus 9 and m plus 3. Take a look at this next one down here. This is a trinomial, but this one's a little tougher because we don't have a leading coefficient of 1. And this is not a perfect trinomial square or anything, so we're going to multiply the 2 numbers together, coefficient of the squared term, leading coefficient here and the constant at the end. We're going to get 36, and we're going to focus on these 2 numbers. We need numbers that multiply to be positive 36 that combine to be 13. So let's see, 6 and 6, you can't make a 13 out of those, but that comes close. 1 and 36, that's not going to work. 4 and 9, I'm hoping that's what popped into your head first. They multiply to be positive 36. They combine to be positive 13. So as long as we do this right, we're going to get, or don't make any silly mistakes, we're going to get the answer right. So I'm going to write 4c plus 9c plus 6. And then I'm going to go ahead and group these. That's why we call this trinomial grouping sometimes. So I'm going to take out a 2 and a c. I'm left with a 3c plus 2. And out of the 9c and the 6, I'm going to take out a 3, a positive 3. I'm left with a 3c plus 2. So again, we've got a 3c plus 2, a 2c plus 3, and we circle that, and we are done. All right. We'll look at this next one. Again, a trinomial, not a perfect trinomial square, doesn't start or end with a perfect square. This is a difficult one. We're going to multiply the two of those together. That's going to be 42. Again, I'm looking at positive 42 and 15, so I need two numbers that multiply to be positive 42 that combine to be 15. So we'll stop and think about this for just a second. Yeah, wait just a second. Let's list out these numbers. 1 and, whoops, let me change colors here. 1 and 42. Okay, those would make a 42. 2 and 21. Let's see, 3 goes in there. 3 goes in there 14 times. Yeah, and let's see, 4 doesn't go in there, 5 doesn't go in there, 6 doesn't go in there. Oh, wait a minute, 6 does. 6 goes in there 7 times. So we can make a, let's see, a 41 or a 43 out of those. We can make a 23 or a 19 out of those. And we can make a 17 or an 11 out of those. And out of here, we can make a 13 or maybe a 1. Can't make a 15. So this one is prime, does not factor. When we're factoring these, we wouldn't bother trying to take out a 1 or anything like that. We just leave that prime. So we'll take a look at the next one. Again, a trinomial looks like it's a tough one, but you'll notice that we've got a common factor of an r in all of these, and they're all even, so we can at least take out a 2. If you double check, we can actually take out a 4. So let's take out a 4 and an r. If we take out a 4 and an r, let's see what we're left with. This would be an r squared. This would be a plus 3r, and if I take 216 and divide it by 4, I get 54, and that's a negative 54. And then we've got an easy trinomial. So now the way to break this down, this is going to be an r and an r. We need numbers that multiply to be, oops, that should be a negative 54. Sorry about that. So negative 54. We need numbers that multiply to be negative 54 and combine to be positive 3. I'll just highlight these. Negative 54 combine to be positive 3. Let's see, numbers that multiply to be 54. 1 and 54, 2 and 27. Let's see, 3 goes in there 18 times, 3 and 18, but you can't make a 3 out of those. It's got to be some numbers that are pretty close together. Maybe you already figured this out. 9 and 6, but one of them has to be negative and the other one has to be positive. Remember, if they multiply to be a negative and combine to be a positive, the bigger one's got to be positive and the smaller one's got to be negative. So let's just double check. Do they multiply to be negative 54? They do. Do they combine to be positive 3? They do. So I can write a negative 6 and a plus 9. And don't forget to put the 4r out in front there. So we've got that one. Oops, bring that back. And then over here, let's go ahead and see if we have a common factor, because this just looks like a mess. I don't mind the x squared and the y squared, but let's take out, let's see what we can take out. I can take a 6. Yeah, I can take a 6 out of all of those. So if I take a 6, but no variables, can't take out any variables, I'm left with a 9x squared. This would be a negative 21xy, and then this is going to be a negative 8. So we can close the parentheses there. Oops, need the y squared on that. And then this is a hard trinomial, so we're going to multiply the two of those together. That's going to be a negative 72. And I'm going to focus my attention on that number and this number right here. So it might take us a little while to come up with this, because I could try and use 9 and 8, 2 and 36. That's not going to work. But if I do 3 goes into 72 24 times. So I'm going to have a 3 and a 24. And again, they need to multiply to be a negative, but combine to be a negative. That means the bigger one's got to be negative. Let's just double check. Do they multiply to be negative 72? They do. Do they combine to be negative 21? They do. So this is going to be 9x squared let's see, plus 3xy minus 24xy minus 8y squared. So we're going to take out a 3 and an x. And if I take out a 3 and an x, I'm left with a 3x. And then let's see, I'd be left with a plus y. That looks good. And then out of this, I can take out the leading sign. That's going to be a negative. The biggest number I can take out is an 8. And I can also take out a y. So that's going to leave us with a, that would turn to positive. Be left with a 3 there. Took out the y, so there's an x left. And then took out the negative and the 8 and one of the y's. So this would be 3x minus y. Oh, this changed sign of both of those. So those are going to be positive. Catch that right there. Taking out the negative. These two are negative, so those are both going to be positive. So we have 3x plus y, and then I'll make that look a little bit better, 3x plus y, and then what's left is 3x minus 8y. And then for sure, don't forget this guy right here. Need to bring that 6 down here, so that needs to sit in front. And then we'll flip the page over, and we'll take a look at the back side and see what we've got there. Okay, we'll take a look at this, and we'll notice that we've got two terms here. They both got a 3, so we're going to take out a 3. We're left with an x squared, and then this would be a minus 9y squared. And if you've got two terms, you might want to check and see if it's a difference of squares. Remember, if it's a squared minus b squared, perfect square minus a perfect square, it's going to be the first one minus the second one, and then the first one plus the second one. So we'll have the 3 out front. That's a perfect square of x, and that's a perfect square of 3y. So this is going to be x minus 3y, and this is going to be x plus 3y. And again, we'll box that up, and we've got our answer on that one. Those formulas make it really pretty quick. Let's take a look at this one right here. Big numbers, and there's nothing I can take out of both of them, but I do notice this. That is a perfect square of 6a. And if you're pretty quick with having those memorized from 8th grade, let's see, 160, that's a 13. So this is 13b. So this is going to be the first one minus the second one, and the first one plus the second one. Again, if somebody were to write the one with the plus first, that's totally okay. Not a problem there. But I like writing it with the negative. I think it has some advantages in the long run. Then we're going to go ahead and take a look at this one right here. This one is a bit of a mess. You'll notice that we don't have anything in common. 23 is a prime number. But it does kind of fit this pattern, though. So we've got an a squared, and we've got an a, and then we've got a b and a b squared. So we might be able to factor this. Let's just check and see. If I multiply the two of those together, that's going to be 126. And then I need some numbers that multiply to be 126 that combine to be 23. So I'm going to look at this. Whoops, I need to get rid of that. I'm going to highlight these two. And then I'm going to look at this, and I'm going to show you a quick little reminder on the calculator. If you're having any trouble with this, you can take the number that you're trying to multiply to be. So let's take 126, and I'm going to divide it by x. And then I'm going to set up the table. So I'm going to do table set. I'm going to start it at 0, and we're going to go by 1, and then I'm going to hit table. And what that will do is I go through, it'll give me all the nice combinations, all the nice factors. So 1 and 126, that would make a 23. 2 and 63, that wouldn't do it. 3 and 42, getting a little closer. Let's see, 6 and 21, that would make a 26 or a 15. 7 and 18, and that's close because that's a 25. 9 and 14, okay, those would multiply to be 126, and we could get those to combine to be a 23. So let's go ahead and use those. So I'm going to write down a 9. Whoops, got to change back to red. 9 and 14. So double check. Do they multiply to be 126? They do, if you want to double check that. And then they combine to be positive 23. So I'm going to have 21a squared plus 9ab, and then plus 14ab, and then plus 6b squared. So out of these two, we can take a 3a. We're left with a 7a plus 3b. Out of these two, I can take a 2. So 2 and a b. Don't forget the b there. 2 and a b, and you're left with a 7a And then if I take a 2 out, I'm left with a 3, and I took a b out, so I'm left with a b. So this is going to be 7a plus 3b, and we're left with 3a plus 2b. And that looks pretty good right there. Okay, so I think we've got that one taken care of. We'll take a look at this. Again, looks ugly on its face, but let's just take out a 2. If you take out a 2, suddenly we have u squared plus 14u and then plus 49. You can do this a couple of different ways. We need numbers that multiply to be 49 that combine to be 14. That's pretty easy to do. You can also recognize that this is a perfect square of u, this is a perfect square of 7, and then this would be 7u, and if you double it, it creates the right middle term. So either way, you're going to have a 2, a u plus 7, and a u plus 7, or a bit easier way to write it would be 2 and then u plus 7 quantity squared. Like that. Good right there, and then there's our answer. Okay, let's take a look at the last couple there. All right, taking a look at number 15, we can take out a 2. That's going to make this a little bit easier. So this is going to be an x squared minus 4x, and then this is going to be a minus 45. We don't have any perfect squares or anything, so I'm going to go ahead and put the 2 right here. And then hopefully this is a factor. We're looking for numbers that multiply to be negative 45 that combine to be negative 4. So multiply to be 45, 5 and 9. And if they're going to multiply to be a negative and combine to be a negative, the bigger one's got to be negative. Let's just double check. It takes an extra couple of seconds to make sure we get this right. They multiply to be negative 45. They combine to be negative 4. So I've got a plus 5 and a minus 9. So we got that all taken care of. Again, we got that 2 out in front there. We've got a 4n squared plus 24n plus 35. No common factors or anything like that. So we are stuck doing this the hard way. If I multiply the 2 of those together, let's see what we get here. So 4, clear this off, 4 times 35. I get 140. So 140, and they're all positive. So they've got to multiply to be 140, and they've got to combine to be 24. We could use that little trick on the calculator, but check this out. Probably the easiest way to make 140 would be 10 and 14. 10 goes in there 14 times. You might try 2 and 70 or something like that, or maybe 20 and 7, but you're not going to be able to make a 24 out of those. So this is the right answer right here. So let's go ahead and write 4n squared plus 10n plus 14n plus 35. Again, when we're grouping these together, notice that we've got some common factors here. I've got a 2 and an n. That leaves a 2n and a 5. And out of here, I can take out a 7. I'm going to take out a positive 7. I'm left with a 2n. And if I take a 7 out of a 35, I'm left with a 5. So this is going to be 2n plus 5 and 2n plus 7. Okay. So even with the big number, it turns out to not be too horribly bad there. And we'll take a look at the last couple. We've got, 6 more to go. Okay, on this one, we've got 4 terms. So let's go ahead and do what we typically do and group those. I'm going to take out an x squared and also a 3. If I take that out, let's see, I'm left with an x and I'm left with a plus 8. I have to take out a leading sign here, so I'm going to take out a negative 5 and I'm left with an x. And again, that would change the sign of that. So I've got an x plus 8 and a 3x squared minus 5. This has 2 terms, but you'll notice it's not a difference of squares, so that's going to be the answer right there. We'll look at this one. Again, we've got 4 terms, so let's take out a common factor out of the first 2. That would be a 7n squared. We're left with a 2n. Take in 7n squared out of a negative 7n squared, and you're left with a negative 1. And then we're going to take out the leading sign here. So we've got to take something out. I like writing that 1 there. If you take a 1 out, it doesn't change anything, but now we can see that we've got these common factors right here. So 2n minus 1 and 7n squared plus 1. Again, not perfect squares, not a difference of squares. There is no such thing as sum of squares or anything like that. So we are finished right there. Let's not get crazy on this one. And take a look here. 2 terms, like we were talking about, the only way that we have right now to factor that is if it's a difference of squares. That's a perfect square of 6x. That's a perfect square of 9y. So that would factor to 6x minus 9y and 6x plus 9y. Now, if you just leave it like this and circle that and say, hey, I've got it done, you're not going to get all the points because it's not completely factored. So sometimes we get a little carried away. So there's two ways that you can deal with this. One would be you can take a 3 out of each one of those. So if I take a 3 out, I'd be left with a 2x minus 3y. I can do the same thing out of here. I can take a 3 out, so that would be a 2x plus 3y. So I'd end up with a 3 times a 3, that would be a 9, and then I have a 2x minus 3y and a 2x plus 3y. Now, that's a heck of a lot of work to get that answer right there. We're going to get the same thing, but we're going to get it a little faster way. Always do rule number 1. So we're going to take out the GCF. So if you take out the GCF, what's the biggest thing that you can take out of both of those? You can take out a 9. So if you do that, you take out a 9, you're left with 4x squared, and you're left with minus 9y squared. Perfect square of 2x, perfect square of 3y, and now we have a 9, and then it's 2x minus 3y, first one minus the second one, and 2x plus 3y, first one plus the second one, okay? Little bit easier, much less work doing it that way. Okay, let's take a look at this one, and let's not forget, take out the GCF if you can. We could multiply those together and get 72, but why deal with that when you can take out a 6 and you're left with x squared minus 3x, and then this would be plus 2. And you're looking for two numbers that multiply to be positive 2, that combine to be negative 3, and the only way they're going to multiply to be a positive and combine to be a negative is if they're both negative. And the only way to make a 2 is going to be a 2 and a 1, and don't forget the 6 out front. So some of these problems go really quickly. Let's take a look at the last couple. Let's see, is there a GCF that we can take out? There's not. Let's see, I could multiply the two of these together. If I multiply them together, I get a gigantic number. But if we recognize something, we might be able to do this really quickly. That is a perfect square. It's a perfect square of 6k, and that's a perfect square of 5. And if you multiply those together, you get 30k, and if you double it, you get the right middle term. So the cool part about this is a perfect trinomial square. It's a perfect square of 6k and 5, and the only thing we need to worry about is the symbol that goes in between there. It's either a plus or a minus, and it's the same as the middle one right here. So that's probably the quickest way to do that one. We avoid all that riddle method and stuff like that. On this one, let's double check. I think we've got a common factor. Yep, we can take out a 3. You're left with an m squared. This would be minus 13m. And if you take a 3 out of a 126, you're left with I think that's going to be a 42, positive 42. So now again, we're looking for, because this is an easy trinomial, we're looking for numbers that multiply to be positive 42, combine to be negative 13. We'll spend a little bit of time thinking about that. We might try 6 and 7. That's not going to do it. 5 doesn't go in there. 4 doesn't go in there. How about 3? 3 goes in there 14 times. But if we think about it, wait a minute, we're trying to make it equal a negative 13. There's our numbers right there. They both just need to be negative, okay? So this is going to be m minus 6, and this is going to be m minus 7. We put the 3 out front, and there's our answers. All right, okay, good luck on the test.